This section is 1.2 on modeling quantities, and it's part 1, which we're going to focus on ratios and proportions. So the first thing that we're going to do is just look at the definition of these items. So we have a ratio, which is just a comparison of two numbers. So often you'll hear things like the ratio of boys to girls was 10 to 21. So you can see it written as either a colon, like 3 to 5, for example, or you could also see it written as a fraction, like 3 over 5. So it's, again, just a comparison of two numbers. The next word is proportion, which is an equation that states that two ratios are equal. So we often set up a proportion when we are missing one of the items. So an example of a proportion is something like 1/2 is equal to 3 over 6, because those are equal items, so we can set them equal to each other. The last thing is a scale. So the scale is a ratio of any length in a scale drawing or model to represent the actual length. So oftentimes we'll see a scale in like a map. So something like 1 inch, when you measure between two cities, for example, will represent 30 miles. So again, please pause if you need to make sure you get these definitions down, because we'll be using them for the next several days. So now what we're going to do is look at a couple problems using these. And just to keep in mind, scale is really the same thing as a ratio. A scale is just a type of ratio that we use. So the first problem we have is a statue that is 90 feet tall casts a shadow that is 45 feet long. At the same time, a 6-foot man casts a shadow that is X feet. So we know that they both are in relation with each other. So we're trying to figure out how long the shadow is that the man casts. So I'm going to go ahead and draw a picture of this. So I'm just going to write the word statue for our statue. And we know that it is 90 feet tall. And then we also know that it casts a shadow, which is 45 feet. The other piece of information we have is we have a man, and this is not drawn to scale, that is 6 feet tall, and we want to know if they are in direct relation with each other, what is the length of the shadow. So in order to do this, we're going to set up a proportion. So we can think of it, you can do it in several different ways, and this is a good problem to do if we are in class, because it's always nice hearing about all the different ways students do, but I'll try and come up with several for us. So we have the man's height and the statue's height. So that's one way to do it. So we have the man's height of 6 over the statue's height of 90. So this is representing the vertical height. And then for the horizontal height, or the length of the shadow, we don't know the man's, but we do know the statue. So again, we have the height over the distance, or the height and then the distance. So in order to solve this, we could actually do cross multiplication. So we have 6 times 45 and 90 times x. So you would do 6 times 45, and this is equal to 90 times x. So 6 times 45 is 270 equals 90x, and you divide by 90, so x equals 3. Okay. Another way to do it is to do something like the length of the shadow. So we would say 45 over 90 is equal to the length of the man's shadow over the height. So again, when you cross multiply, you would end up getting the same thing. 45 times 6 equals 90x. So either way, another way you could do it is notice the relationship between 90 and 45. So how am I getting from 90 to 45? Well, you're dividing by 2. Okay, so then how do I get from 6 to x? You divide by 2. And so that's why it ends up being 3. And in this case, we're talking about 3 feet. So the only problem about that last way I was talking about of how do you get from 90 to 45, it's not always that simple. So it would be in your best interest to set up a proportion. All right, we're going to look at one more problem. This one's talking about a map. So we're still going to be setting up a proportion, but we're going to use the scale to help us do that. So the actual distance from Chicago to Evanston is 11.25 miles. We want to know what is the distance on the map. So that means if I were to measure it, what would it be? So we're talking about inches because it gives us that scale. So again, we can set this up in a couple different ways. I'm going to make a proportion. So we have the map and then we have the actual distance. So for the map, we know that 1 inch is 18 miles. So we want to set that equal to our other ratio, which is 11.25 miles is how many inches. So we don't know the amount of inches, so that's going to be my x, but we do know that it's 11.25 miles. So you want them to be inches with inches and miles with miles. So again, we are going to cross multiply. So I would do 11.25 times 1 equals 18 times x. So that's just 11.25 equals 18x. Then in order to get x by itself, we want to divide by 18. So x equals 0.625. And in this case, it's 0.625 inches. And let's think about if that really makes sense. Well, we know that 1 inch is 18 miles. So if we're talking about 11.25 miles, it wouldn't make sense for it to be 1 inch. It has to be less than 1 inch. Now, if I said something like the distance was 25 miles, then we know that it would be more than 1 inch. All right, so the last question is a your turn problem. So you're going to do this one on your own. So we have a scale model of a human heart is 196 inches long. The scale is 32 to 1. So again, you want to set up a proportion with the scale and then with the information you have, which is 196 inches long. So in this case, the scale model is a larger. So often when we have a scale model, it's a smaller item, but this heart is enlarged. So it might be in something like a museum or something. So go ahead and do this problem and then go check back at your solutions on the website.